We are in the same situation in question number 3 as in question number 1 and 2. First of all, we notice we have a variable here, something which is squared. So we have variable square minus a number. And that's very important if we have this scenario. There is a procedure to do, especially if you have this square root. And if you remember of what we did before, if we have this situation, okay, which is, let me write it up here. If we have something squared, which is t squared minus a number, which is usually it is a, we just take x or t or whatever that is squared, and we take square root of a, and then we take secant theta. So that's the substitution I will use to solve this question. So here I'll write t equal square root of that number secant theta. Now this number is 16, so I just take square root of 16, which means t equal 4 secant theta. And that would give me that dt, the one that in the numerator, is equal to the derivative of secant, which is secant theta tan theta d theta. Now we take this information, we replace every t by 4 secant theta, and we replace dt by 4 secant tan dt. Doing this replacement should simplify the question for me, and I should be able to do the integration. So this was the question, t squared t squared minus 16. Now if we do the substitution, if I remove dt, I will get 4 secant theta tan theta d theta. Down here I should get t squared, which is 16 secant squared theta, and then I have a square root of 4 secant theta squared minus 16. If we simplify this a little bit, this should be the following: 4 secant theta tan theta d theta, and here we get 16 secant squared theta square root of 16 secant squared theta minus 16. Taking the 16 as a common will help me in this question, so let me do that. I will not do any simplification so far. I'll just keep the simplification for later. 16. Now take the 16 as common factor. This will be secant squared theta minus 1, and that's what we should get. Now zoom in. This one we know it, and that's the whole story is about to get into this one, because this is simply tan squared theta, and that will simplify the integral for me. So this would be integral of, the numerator would be the same, here the secant square, the first one is the same. Now whatever inside the square root is simplified into 16 tan squared theta, which is, if we take it outside the square root, it is nothing but 4 secant theta tan theta, and here is 16 secant squared theta times 4 tan theta. Now I think we can do cancellation, and it's easy to cancel. I can see that tan can cancel with tan, 4 with 4, secant with one of the secants. So what is remaining for us is 1 over 16 can go outside, integral of 1 over secant theta d theta. Now what is integral of 1 over secant? It reminds me, what is 1 over secant? It's simply cosine theta. And the integral of cosine theta is just sine theta plus c. That's the big picture that we have here. So all what we need to do next is to replace this sign and write it in terms of t. Now, if you remember, and this what we did before, let me just prepare everything. Sine is always, with respect to theta, is the opposite over the hypotenuse. All what we need to do next is we need to find how much is the opposite and how much is the hypotenuse plus c. Let's find the opposite in the next page. Now, how do we find the sine of theta? We have to see what was the equation between t was equal for secant theta. This means that secant theta is t over 4. And if we draw any right triangle and this is theta, the secant is the opposite of cosine, so this will be hypotenuse over the adjacent. Comparing so between the hypotenuse and the numbers here, we can write this is t and this is 4, and what is missing for me is the opposite. Now, how do we find the opposite? That's the question. We will use Pythagorean's theorem, which says that opposite square plus adjacent square equal the hypotenuse square. The opposite, which is something we are looking to find, adjacent, which is 4, so it will be 4 squared 16. Hypotenuse is just t squared. If we take the 16 to the other side, it will be t squared minus 16, and so the opposite will be just the square root of t squared minus 16. It should be a plus, not a minus. Usually we write here a plus minus, but the minus, because we are talking about a length, it should be just a plus one. If you watch question number 1 and 2, this was the idea. It always, in a trigonometric substitution, is a mechanical way to solve those questions. It will all go the same way. Nothing will go wrong if you follow the steps. So, going back here, writing final answer, it will look like this. The opposite, which we just found, was t squared minus 16, and the hypotenuse was just t. And that is the final answer for this question. Thank you very much for watching, and we will see another question in a minute.